Alright, today's lesson is 2-6. Today's date's today, and our objective, we're going to solve a variety of equations by factoring, and we're also going to do the rational root theorem. So the first one that we're going to do is we're going to solve by grouping. And what I'm going to do is actually put parentheses around the first two terms, and then I'm also going to put parentheses around the second. Be careful here because that negative sign belongs to the 4x, and inside the parentheses I want to make sure it still has that negative sign. Now I'm going to look for a greatest common factor. For the first term, my greatest common factor is x squared. And when I factor that out, I'm left with x plus 5. On my other term, I'm going to factor out a negative 4. Oops, put a square there and I didn't mean to. And I'm going to be left with x plus 5. Now factoring only works, factoring by grouping only works if what's in the parentheses is exactly the same. In this case it is, it's x plus 5. And then in the other set of parentheses, you put what's left over, x squared minus 4, which that's a difference of 2 squares. So now it's completely factored. Just take each one, set them equal to 0, you get x equals negative 5, negative 2, and positive 2. Let's do the same thing on the next one. I'm going to put parentheses around the first two. And remember, that negative sign goes with that 2. So if you can draw that a little bit better. Out of that first term, I'm going to factor out a x squared. And I'm going to be left with 2x minus 1. On the next one, it's really close to 2x minus 1. I have negative 2x plus 1. I'm going to factor out a negative 1. And that changes the sign of everything. I have the same thing inside the parentheses. And I'm left with x squared minus 1. That's a difference of 2 squares, so I'm going to go ahead and factor that even further. 2x minus 1, x plus 1, x minus 1. I would take each of those factors and set them equal to 0, and I get 1/2, negative 1, and positive 1. Let's do one more example. Here, the first two go together. The second two go together, and this one's nice because there's a plus sign in front of that 8x. I don't have to worry as much about signs. Let's factor out an x squared. I'll be left with 2x minus 3. Here I'm going to factor out a 4. So now I've got the same thing in each box, or each set of parentheses. So that would be 2x minus 3. And x squared plus 4. I know we've been factoring difference of 2 squares, but this is a sum. That does not factor. So I'm going to take each of those, set them equal to 0. When I solve that, I get x equals 3/2. Here, I would subtract 4. Then I would take the square root. And when I get the square root of negative 4, it's plus or minus 2i. So I'm going to have a couple imaginary solutions on this one. One real solution, so I know it's crossing the x-axis in only one spot. Now we're going to use the quadratic form. On the quadratic form, what I'm looking for is that first degree has to be even. In this case, it's 4, which is even. And then our second one has to be half of that. So half of 4 is 2. Because what I'm going to do is I'm going to let y equal x squared. And if I were to make a substitution, that's really x squared, quantity squared. So if I take out that x squared and put y in its place, I'm going to be left with y squared minus 3 times y minus 4 equals 0. That's something I'm going to be able to factor. Y minus 4, y plus 1. Let's go ahead and make our substitution back in there, because I know y is the same thing as x squared. Let's take each one of those and set them equal to 0. Add 4, take the square root. Don't forget your plus or minus. Get plus or minus 2. Subtract 1. Take the square root. And you can get two imaginary numbers here, positive I and negative I. Okay, again, I'm going to let y equal x squared. So I'm really going to have a y squared minus 7y minus 8. Go ahead and factor. Let's go ahead and make our substitution again, now that we've factored. Add, or take each one of these, set them equal to 0. Add 8. Take the square root. And I'm going to go ahead and simplify the square root of 2 as 2 radical 2. And don't forget your plus or minus. Here, I'm going to have x squared plus 1 equals 0. Now this is the same one that we just did. X is going to equal plus or minus I. Right on this one. Again, I'm going to make that same substitution. Y equals x squared. So I'm going to have 2y squared plus 3y minus 20. And the way I'm able to do that at the beginning is x to the 4th is the same as x squared squared. Let's go ahead and factor. Let's see, my factors of 20 are 4 and 5. Let's put a 4 here, a 5 there. And if you want to, that's my guess. If I want to check myself real quick, that's negative 5y. That's positive 8y. If you add them together, you do get 3y. So now I'm going to go ahead and make my substitution, because I know y is the same thing as x squared. Take each one of those factors and set them equal to 0. Add 5 to both sides. Divide by 2. Take the square root. Over here, I'm going to subtract 4. Take the square root. On this one, all I'm going to show you is that you can factor it even if it is not, if it's higher than a 4th degree. The main thing is it needs to be an even degree, and the middle term has to be half of it. So we've got an even degree with 6, and half of 6 is 3. So this time, I'm going to let y equal x cubed, because that would be the same as x squared or cubed, quantity squared. That is the same as x to the 6th. So I'd be left with y squared plus 26y minus 27 equals 0. Y plus 26, y minus, oops, let's try that again. How about y plus 27 and y minus 1? Because they multiply to give me negative 27, add to give me 26. And then I'd be left with x cubed plus 27, x cubed minus 1. Well, we have the sum and the difference of two cubes. Those can actually be factored. If I weren't teaching the honors class right now, I would go ahead and factor those. On this example, I just wanted to show you that you can factor it. All right, rational root theorem. I'll give you a second to read that over. We did this in Algebra 2. The gist of it is you have possible roots. We don't know which ones they are, but possible solutions are your factors of p over q. P is your constant at the end. Q is your leading term. So, if I started this one and I tried to do grouping, it's not going to work. And I'm going to ask myself, well, geez, if only I knew a few possible roots. Well, I do. My factors of 2 are 1 and 2. My factors for 4 are 1, 2, and 4. This is my P. This is my Q. And I know my possible roots are P over Q. I probably should have put some pluses and minuses in front of all of those. So, if I want to figure out every single ratio, it's 1 over 1, 2 over 1, 4 over 1, 1 over 2, 2 over 2, which is 1, we already have that down, and 4 over 2, which is 2. We have that one down as well. So those are just possible roots. We don't know which one it is, but we can test them out to see which one works. So it's usually just kind of a guess which one you want to go with. I usually start with my smaller positive numbers first, and then work my way towards the fractions. So let's go ahead and put 1 in the box. And my coefficients from my equation are 2, negative 9, 3, and 4. And from our previous sections, we know if the remainder is 0, we have a root. So bring down the 2, multiply, add, multiply, add, multiply, add. And we get lucky on our first trial. That is a root. So we can say that right now. X, not x squared, x equals 1. So there's our first root. And I could sit there and continue to try those different roots, or I can say to myself, well, I have a depressed polynomial, x squared minus 7x minus 4. I think I can factor that, or worst case, I could use the quadratic formula. Minus 4, positive 1. Take each one of those factors, set it equal to 0. And you get x equals negative 1/2. And x equals 4. So those are my roots. So we just solved a cubic function without a calculator or a graph. There is your assignment.